Okay guys, let us talk about thermal expansion. Okay, thermal expansion. So what is thermal expansion? So almost all solids are found to expand with the rise in temperature. We know that when we give some temperature, some heat, some fire, then almost all solid expand. We know that allow fan trinity country kaka thermal expansion of solid kantia. So thermal expansion are of three types. We must know that thermal expansion are of three types. Number one is, so I shall talk about, so that is about thermal expansion. So tuna hand control hilenkim solid thi allow fan thaya by giving temperature, by applying heat energy or fire. Okay, when we put under fire it will expand. Okay, that is thermal expansion simply. So the number one is, there are three types. Number one is a linear expansion. Okay, what is linear expansion? So for example, this is an iron rod, a small iron rod. So if I give some heat for a few minutes or for a few hours, then this iron will expand a little bit. You know that it will expand a little bit. Low fan only. Not only iron, if we apply a fire or heat to copper, maybe aluminum or silver, whatever it is, rod kalo fandoni, it will be elongated. Allo seisat donani, so it's elongated. Okay, it's elongated. So the expansion or the elongation of an iron rod by applying heat is called linear expansion. Okay, it will be expanded. So you have to know two things. Number one is, so this iron rod, the expansion will be depend upon its original length. Okay, its original length. That is, if we express in equation L prime minus L small l is directly proportional to original length. This is equation number one. Let's say equation number one. What is L prime? This is the change in length. Okay, change in length. L prime is change in length. Change in length means the when the L is elongated, that part is called L prime, and where L is the original length. Okay, so it's all. And also number two, if I give heat more and more, the quantity of heat more and more, or the duration, if we give more time, so the temperature will rise, and so also the length will become expanded more and more. Allow say to donni temperature tam po le khan chuwang chuan, that means the change this length, the change in length is also directly or the increase in length is also directly proportional to the rise in temperature or change in temperature, which we call delta T, equation number 2. Okay, so these two things happen. And if we combine these two equations, L prime minus L is directly proportional to L delta T. Okay, so or we can write like this, or L prime minus L, which is equal to some constant value L delta T. What is constant value? So here we shall put alpha. Okay, in place of K is constant. L prime minus L equal to alpha alpha L delta T. So this is the final equation for the increase in length. Increase in length, equation number 3, let's say, equation number 3. So what is alpha? Alpha is called coefficient of linear expansion. Okay, coefficient of linear expansion, alpha. What does coefficient of linear expansion means? So if we apply to iron rod, it will expand it to some extent through elongation at the same temperature, the same duration, and the same volume with copper. If we change with copper, daramo, aluminium, mass elongation all will be different. In anglo vecdon, same temperature, though we give same temperature, temperature ngai ring kan pek pon kan mei kan same temperature apply pon, so the elongation all so different metals will behave different way, means their elongation will be different. Asrang trip don change in length will be different in each material. So that means they have different properties, which we called is a coefficient of linear expansion. So they have some constant which is very, very important. Constant value nei kan titani chu til poimo tak khan lo ni tani til kim kha khamit ti shrang tu. What makes that difference? What makes this difference? Question mark. It is because the coefficient of linear expansion. This is very, very important. So each property of a material means iron, maybe copper, or maybe aluminum, they behave differently with the same temperature because they have coefficient of linear expansion. Okay, so that is about coefficient of linear expansion and coefficient of linear expansion, or the change in length or the increase in length when we apply some heat. This is the formula. So next is, okay, number 2 is we shall talk about superficial expansion. Okay, superficial. What does superficial means? Superficial, let me take this. Instead of an iron rod, this is plate. So if I heat this plate for a long time like this, for a long time, this area, some area will enlarge, means expanded, or maybe the whole portion of this area will be expanded a little bit. Area or this spoon, if we give some heat to this spoon for a few minutes, then we will see that some change in area a little bit. So the expansion in area is called the superficial expansion. And also, just like before in the linear expansion, if we use different materials like copper, iron, aluminum, they will behave differently with the same amount of temperature, the same amount of heat. That is also coefficient. Some coefficient, they have some properties, but here we call that it is a coefficient of superficial expansion and detani. Now we shall write some equation. This also, number 1, it behaves, though the change in, we shall write is S, means superficial, or change in area is directly proportional to original area. And also number 2, this will be directly proportional to the rise in temperature if we give more heat more. And so if we combine rise in area or the increase in area is equal to some constant value. With this constant here, we shall put S directly. Okay, so beta, this constant is beta. So in superficial expansion, the constant value, which is called the coefficient of superficial expansion, is beta coefficient. So I shall write in shortcut coefficient of superficial expansion. Okay, so this coefficient of superficial expansion. So this is again the important formula or relationship. And I have forgot to tell you that the SI unit SI unit of this super linear expansion. Okay, so the SI unit of this alpha is a per Kelvin, K to the power -1 in SI. You must know that. And also we have the same SI here, beta. It is per Kelvin, is SI. Okay, in SI is per Kelvin. So you must know that. And the third one, okay, what is the third one? The third one is cubical expansion. Cubical expansion. Cubical. Okay, so what is cubical expansion? For example, this spherical ball, you will give some heat, then the whole body will get enlarged, will expand it. Okay, the whole body, not only one surface, the whole body. Apumpuika, allow volume will increase, allow and shut down. And also this, if we put under fire, this one in iron, some iron, small in length, if we put under fire, and then the whole body will change its shape. The whole body, not only one surface, this side of this cylinder, though it is a cylinder, but the whole body will change if we put under fire. So as a fire can rot one alolian shutdown, and also this. So the change in the whole body, expansion in the whole body, is called cubical expansion when we give some heat. Okay, so cubical expansion is the change in the whole body, the volume of a body, from the original to the increase in volume by applying heat. Okay, so if we can also write like this: number one, same thing as in superficial and linear expansion. Change in volume or the rise in volume is directly proportional to the original volume. And number two, this will be directly proportional to the change in temperature or the increase in temperature. If we give more and more heat, then the volume will increase more and more. Okay, so if we combine these two things, it will look like this, is equal to some constant value. I shall put directly this constant in cubical expansion is gamma. So instead of using alpha, beta here for cubical expansion, we use this gamma. Okay, so V delta T. So this is the expression of the increase in volume by applying heat to a body. Okay, whole body. So this, what is this gamma? This is also coefficient of cubical or volumetric expansion. Cubical or volumetric expansion, this is also a coefficient. That means if we apply the same heat to an iron ball, or to a copper ball, or to a steel ball, or whatever it is, the expansion, by applying the same amount of heat, the expansion will be different. The increase in volume will be different for each material of the body. Material frang kan mangani chun alin da nang mi lawang heat inang raw raw khan chu chu nge chan kan ti chun. What is the reason? It is because of this coefficient of cubical expansion to allow on. So the gamma is very important. Okay, so now we learn about thermal expansion. Expansion in a solid can expand by applying heat, but different amount for the same temperature. It can be elongated. When it is elongated, we call it linear expansion, and when its area is increased, then we call it superficial expansion, and when its whole body is change in shape or change increase in volume, that means we call it cubical expansion. Okay, so that is all about thermal expansion.